Welcome to another lesson on radiation. Today we are looking at alpha, beta and gamma. We're going to find out what they are. So first thing, we've got some do now questions. There's 4 there relating back to previous lessons. So if you could answer those, pause the video and then unpause the video when you've written your answers in your notebook. Okay, so what is an isotope? An isotope is an atom with an imbalance of protons and neutrons. Okay, so we said that it's an atom. It has the same number of protons but a different number of neutrons. Okay, so we looked at hydrogen that has 1 proton, and then the isotopes can have 0, 1, 2 or 3 neutrons. Okay, what is background radiation? It's radiation that's all around us. Okay, and that comes from natural and non-natural human activity sources. Okay, name a source of background radiation that's caused by human activity. So there's medical. There we go. Medical. We get fallout from nuclear testing. Okay, and then we get nuclear waste. Okay, from nuclear power stations. Okay, 2 natural sources of background radiations. So we could have plants, cosmic rays, food and drink, and then rocks and soil. Okay, and obviously those rocks are used to make building materials. Okay, so we're going to move on to, make sure you got those written in your booklet, and then we'll move on to finding out about alpha, beta and gamma. Okay, so there we're going to find the information, and then we're going to answer our review questions, and then fill in a table, and then finally you're going to answer some questions about alpha, beta and gamma as your final part of the lesson. Okay, so there are 3 main types, or 3 types of radioactive emission. Okay, these are given off by an unstable isotope when it decays to become more stable. Each is emitted from the nucleus of the atom. Okay, so we have alpha, beta and gamma, and these are their symbols. So this is alpha, it's the Greek letter. This is beta, again a Greek letter, and this is gamma. Okay, so to draw those, alpha, beta, gamma. Okay, so looking at a diagram now, and we're going to look at the penetrating power of alpha, beta and gamma. Okay, so they, as we said, they come from the nucleus of an atom. Okay, so it starts off in the atom. Okay, and then the alpha is going to come out and it's going to hit this piece of paper and it's going to stop. Okay, beta, again, it's emitted. Okay, it can go through the paper, but it is stopped by a thin layer of aluminium. Okay, and then we have gamma at the bottom here. It's a high energy electromagnetic wave, and that will be stopped by lead, thick lead, a few centimeters of lead, okay, or thick concrete. Okay, they are also stopped by other things that we're going to look at in the information pages that we're going to look at now. Okay, so alpha is a helium nucleus emitted from the nucleus of a decaying isotope. It is made up of 2 protons and 2 neutrons. Therefore, it has a mass of 4 and a charge of 2. It is very ionizing because it has that charge of +2. It can only travel about 10 centimeters in air and is absorbed by skin or a sheet of paper. Alpha is very slow moving, and that's because of its high mass. Okay, so we're going to look at our review questions now. You'll be able to come back to this page by rewinding the video to help you answer these questions. Okay, so look at these questions then. And then pause the video and answer those questions. Okay, so what is an alpha particle? So it is a helium nucleus. Okay, we could also say is 2 protons and 2 neutrons. Okay, what is the mass of an alpha particle? Okay, because it's got the 2 protons and 2 neutrons, we can say its mass is 4. What is the charge? Because it's got the 2 protons and no electrons, it's got a charge of +2. Okay, the relative speed of an alpha particle, so compared to when we compare alpha, beta and gamma, the relative speed is slow. Okay, and what's the penetrating power of the alpha particle? Okay, so the penetrating power is poor, okay, but we say can travel about 10 centimeters in air, okay, and absorbed by paper or skin. So quite safe if it's not in the body, because it can't get in the body through the skin. Okay. Also, it'd be absorbed by your clothing, because your clothing is usually thicker than the paper. Right. So next we're looking at beta. Okay. So beta are fast-moving electrons emitted from the nucleus of a decaying isotope. Okay. Because they're an electron, they have a charge of -1, and they have almost no mass. Okay, beta radiation is moderately ionising. It only has a charge of -1. When we compare that to alpha, that's got a charge of +2, it's not as ionising as alpha. Beta particles can travel about 1 metre in air, so they can travel far further than alpha in air, and are absorbed by a thin sheet of aluminium foil. Okay, so kind of like the stuff you'd use at home or in your cookery lessons, that will absorb beta radiation. Beta radiation is relatively fast moving. Okay, so again, review questions, so pause the video, you can rewind the video, look at the information. We need to answer these questions, okay? So what is a beta particle? It's a fast moving electron. Okay, what is the mass of a beta particle? So we can say almost 0. Okay, what's the charge of a beta particle? Well, it's a fast-moving electron, so it's an electron, so it has a charge of -1. What's the relative speed of a beta particle? It's fast. Okay, it's not the fastest, but it's very fast. And what's the penetrating power of a beta particle? Okay, so travels about 1 metre in air, absorbed by thin aluminium foil. Okay, so make sure you've got those written down in your booklet, and we're going to move on to gamma. So gamma radiation is high frequency, high energy electromagnetic rays. It's not a particle, so therefore it has no mass and no charge. Because it's got no charge, it's not directly ionising. Okay, gamma is not stopped by air, so it can travel in theory infinitely, but it is stopped by a few centimetres of lead or several metres of concrete. Okay, gamma travels at the speed of light, so it's the fastest of our radiations. Okay, so we've got some review questions, so you're going to pause the video, you're going to answer the questions. Feel free to go back in the video to look at the information on the previous slide. Okay, so what is a gamma ray? It's a high frequency high energy electromagnetic wave. Okay, so what's the mass of the gamma ray? It's 0. What's the charge of a gamma ray? Again, it's 0 because it's not a particle, it's got no charge. The relative speed is extremely fast. Okay, so we're going to write speed of light. Okay, and nothing can travel faster than the speed of light. Okay, and what's the penetrating power of gamma ray? So not absorbed by air. Okay, a few centimeters of lead or several meters of concrete. will absorb it. Okay, and when it's absorbed, it's stopped. Okay. So now you have a table that you need to fill in. Okay, so this may look a little bit daunting, but you've already answered these parts. All the questions that you've answered earlier on, you just need to put the information in. Okay, so we can write the symbol in. So I'll write the symbols in for you for alpha, beta, and gamma. You need to tell me what it is. Okay, that was the first question on the review. The charge, the mass, the relative speed, and the penetrating power for each one. Okay, so these are things that you've already done. Okay, so I'll just write the symbols in. So we've got alpha, beta, and gamma. Okay, and the rest you will be able to do. Following this, completing this table, there are some questions in your booklet just underneath that you need to answer as well. Okay, all you need to write is alpha, beta, or gamma for each question in your booklet. Okay, if you have any problems, please write a little message to your teacher underneath the assignment post in your team. Okay, right, thank you very much. Good luck.